right. So right, yeah. So a few things. I'm going to. I'm still learning how to use Zoom, but I think I'm getting the hang of it now. So we'll be using this for. We'll be using this for the rest of the semester. So the plan is to do the sessions at the class time. So for instance, today is Tuesday and Thursday at 6 o'clock. So we'd be meeting from 6 to 7:40. Okay. We're still gonna do lectures and labs. We'll talk a bit about the labs. As you know, we don't have access to the hardware anymore, and so I'll answer your questions, and we'll talk about the labs going forward for the semester. Okay. Okay, so we will talk about those issues. One thing I want to point out, so we're doing the sessions like this. However, I'm not taking roll call, so I can't really. I'm letting people in. So I'm not taking roll call, but so you're encouraged to attend these sessions. However, I am recording them. Okay, so I am recording the sessions. So if I click on here, right, I'm recording the sessions, and I will be posting them on this website. So if you looked on Blackboard, I created this link. It's just easier for me to post things here. So you can just check the calendar. You can just check the calendar, and you'll be able to see kind of where we are. So for instance, so far, the last lab that you guys worked on was the firewalls lab. All right, so I believe some people asked me to extend the deadline, so I believe it's extended to April 2nd now, given that, everything that has happened really in the last 2 weeks. So that was the last lab, and then we did the midterm exam. So you did that over the online. Okay, and then on Thursday, I posted a video on risk assessment. So this is, if you please look through the video, this is something that in the video I explained it, but basically something that we used to do with information services at Purdue, at the university. We would usually do this with them, with like the IT people at the school. They would take every group, assign you a building, and then based on that building, you would do a risk assessment. You ask them questions. Unfortunately, obviously we can't do that this semester. So, but I still believe we can do the project. Okay, so I believe we can do the project. And so please go ahead and look at that video. I've explained it very clearly how you can do it. And I asked in the video for every group to send me an email. All right, so please watch the video and then send me an email just kind of saying what you think you will be doing, okay, for this project. So the video is there. Videos are loaded on YouTube just because it's just the easiest place to have them. All right, so you can take a look at them. And I'm recording these, okay? So that's one thing. So that's the risk assessment. And then after that, we're going to talk about the labs going forward. So we have about 5 weeks left in the semester. Obviously, we have to adapt the labs a little bit. But we're still doing seed labs, and the seed labs, usually are made in such a way that you can actually do them with VMs as well. And so that's the good part. So unfortunately, you will not be able to do it with the Cisco equipment that we had in the class, but I still believe that I'm going to go over the lecture today, and I believe you'll find this project this lab, the VPN lab, very, very interesting. Okay, so basically so check this website, check your Blackboard. I also reordered Blackboard a little just to make it a little bit more online. And then finally, always check your email. I will send emails, and I will check my email as well. Office hours, they're going to be also through this medium, Zoom. So usually on Thursdays between 2 and 5 p.m. you can just come into the same Zoom. I will be like connected in, or you can schedule something with me by appointment. Okay, so I think that's, before we start with the topic for today, I think that is all the reminders. You already had your exam, so no more exam. I did explain some things about in the video as well. For instance, we're not going to be able, unless things change and they reopen the university, which is sounding very unlikely at this time, we're not going to be able to do a practical exam. So you will not be able to do it with the hardware. We had thought about initially that you guys could go and get the equipment and have it at your home, but now it's, with social distancing, you can't even be in the same. So that wouldn't work. However, we're doing network security, and that's networks, right? So I'm going to propose some ideas for the VPN Lab, which I think could be very interesting to you. All right. So I think those are all the reminders that I had to give you. So at this point, I'm going to open up to see if you have any questions in particular about anything. So can you guys hear me, first of all?
Yes, we can hear you.
Okay, great. So are there any specific questions, guys?
Not for me. I don't know about everybody else.
Everyone? Anyone?
I'm good.
Okay, so, all right.
I have a question.
Yeah?
I'm trying to keep the mic down for my daughters are playing next door. But anyway,
you can mute it if you.
The question I have, so we're not having a practical final exam. What's your idea then that we're going to do?
Something it's going to be a written exam. It'll have to be a written exam.
Okay.
We're still going to, I still need to fit something into a final, right? So usually I just do the practical exam, and it would have been everything from the semester. Now it'll have to be I mean, unless you have an idea, there's nothing that I can. Presentations are going to be videos from you guys to me. All right. Kind of like this somehow. Zoom, maybe. That Zoom might actually be the way to do it. Or videos. Practical will have to be a final exam, but I still think that all the labs can be done, right? With tiny modifications, we can still do the labs. We had done about 60% of the labs anyway, right? So we were done. The lab that we do after the spring break is the Vpn Lab. And so I still, it's saved for last because it's not a 1 week lab. This is definitely going to be the most challenging lab, but it's a fun lab. It should be very interesting. It would have been great to do it also with the equipment, but with the ASAs, but unfortunately, we don't have that.
Okay, another question would be, yes, everything we've done thus far with the Cisco hardware, we can do most of that with the packet tracer, is that correct?
But so why would you want to, so why do it again? Are you saying like in the practical doing it on packet tracer?
I was just wanting to keep the knowledge up. If I just let it go, it's gone. Whereas if I practice with it, I'm still going to keep it and remember it.
So packet tracer, you can't do everything with it. You can do some things. You can do ACLs, but it's not going to be exactly the same approach. So yeah. So what I can tell you is what we would have done in this semester is we would have done a hardware VPN and a software VPN. And so right now we're only going to do the software VPN. That's my plan, because the hardware VPN would have entailed, setting up the service on the Cisco ASA, connecting that to Active Directory, and then connecting from switch 3 to ASA and getting access to an internal machine in switch 1. Do you understand? And everything would have done through that wizard. So you guys actually got to see the wizard. Do you know what I mean? So it wouldn't have been command line. The VPN, I never do command line configuration. And because as you will see in the software VPN lab, it takes a lot to do it. Okay, and so it would have been just configuring through the wizard and setting up a domain controller for Active Directory search, setting up a group VPN, right, and creating accounts inside. Then on the inside, you would have an FTP server. You would need a VPN client software on the remote worker, which would have been on switch 3, and then you would be able to connect that way. Do you understand what I'm saying?
Okay, that sounds
So
cool.
that's the hardware VPN lab. It's in essence, it's not that much really, but you can try to do it on Packet Tracer. I mean, you know, that's at this point, I am not, you know, I'm not gonna make it a requirement. So that's what I can say. And then there would have been, so there was also the 24 questions. If you look, remember there was that handout of the 24 questions that usually I said, do all of these to make sure that, you know, these are kind of the questions you'll get on the practical. Remember that document? So in that document, you guys have already done some of that, because when you did the demo on week 3, you actually did like bullets, I think like 1 through 6 or 7. But you didn't do a few things on it, you know, where you had to create some ACL. So what I may do at some point is just kind of do a lecture summarizing what that would have been, but not really ask you to do it. I mean, that's, you know, given that we don't have the equipment. Does that answer your question? Yes. Okay. So, and then we're still going to do the software VPN lab. Now, the software VPN lab, I usually do it in a simpler way, right? We don't do everything. This time around, we can expand it. So usually you can do it just with VMs, but given that you guys are in different locations and you have your own routers, it might be good to try to make a VPN between, say, Daniel's house and Corey's house, right? So, you know, and you build a VPN yourself via software. Did you guys hear me?
Yeah.
All right. Yeah. So what I'm saying is we're going to try to extend that. Okay. We're going to try to extend that the software VPN lab and basically the hardware VPN lab. I'm going to try to just combine it into like a some slides or something. If you still want to try it and do it on Packet Tracer, you could for bonus points. We could talk about that. But at this point, I wasn't planning on requiring it anymore. And then we have one more lab, which is the Anomaly Detection Lab. It's like IDS lab, a little bit different. And that should be an interesting topic as well. Okay, so that's basically the plan. Certainly, I think this VPN lab, we'll start it today, and you know, we'll talk about the ideas, and then we'll think about how maybe we can adapt it, as I said, beyond the VMs to the fact that you guys are in your home, so maybe you can connect both ends. Are there any other questions?
No.
No? All right. Okay, so no questions. Yeah, Dan, you have a question?
I put one in the chat. For the VPN software, I want to clarify so that I understand what you're meaning by software VPN and hardware VPN. And basically, the idea I get with a software VPN is that it runs on a machine within the network and not, whereas a router would be considered a hardware VPN if you're doing VPN through the router.
Let me put it this way. Let me answer it this way. A Linux machine and a router, so a Cisco router and a Linux machine with 2 cards, both routers. You know what I mean? So it's the same principles that would apply to the Cisco router that will apply to the VM router. if that makes sense. The only thing that would change is the syntax. Obviously, it's going to be Linux syntax versus firmware of Cisco ACL syntax.
So basically, the Cisco ACL with like ASA or PIX would be considered hardware VPN.
It would be considered a dedicated appliance. It's an appliance. It's a VPN appliance. What we're going to do is we're going to make, okay, let me put it this way. You go to Cisco, you buy a VPN appliance, right? And you put it in your house. We're not going to do that because we don't have those physically, but instead we're going to try to turn a Unix, a Linux 1604 Ubuntu into a VPN. Does that make sense? And so once we make, so it's going to be not a VPN appliance, but a VPN server.
And we're considering this to be called software?
That's why I'm calling it software, because we're gonna write C code.
Okay.
Remember that for anything to be efficient, it has to be in C. If we did it in Python or something, there's too much overhead. So we got to do it at a very low level, hardware level. And so obviously we're doing it on VM, so it's still not like the most robust, but it should actually clarify a lot of things. So it is involved, but the code is already available, you know, so it's not like you have to write it from scratch. We're also, I should clarify, we're not using OpenVPN. So OpenVPN would be like the software implementation of a VPN that you just do sudo apt-get install OpenVPN, done. We're not doing that. Instead, we're literally coding it, all right? But the code is already written. So I have to kind of explain how all that works. And there's going to be a lot of routing that's involved. You know, you have to put in the routing tables of all the VMs, you have to put information. You know, just kind of like we did with the gateways in the physical network, right? So gateway forward to that, forward to this, you know, we're doing kind of the same, but this time we're going to have to add the routing in the routing tables of Unix, of Linux itself. Now, if you at home have access to your router and you can also put routing rules there, then you can that's the only thing that would stop you from building a VPN from your house to Corey's house. If both of you can get into your home routers, then you could definitely build a VPN between the two houses. Does that make sense?
It does. It does. Along those lines, are we going with a login version or a one that's perpetually connected as a separate network?
So ours is not that sophisticated. Okay, so we're gonna use, basically we're gonna establish the tunnel, and then once the tunnel is established, it's established. So, you know, there's no real putting in a password or anything like that, because we're building this from scratch. What you should imagine is first we have to build a tunnel. The tunnel is the first thing that needs to be built, and that tunnel is going to be not encrypted first. But we build the tunnel, and then in the C programs themselves, we have to do the encryption. And that's pretty much your 350 class. Everything you learn in that class about encryption through software, that's, you know, what needs to happen. Except that if you remember, for instance, we use OpenSSL commands, but we know that there's also an OpenSSL library. Do you know what I'm saying?
Yes.
So that's really the idea. So there's a lot of information there, but hopefully it'll become more clear.
Okay. I think I'm going to quit asking questions and let you get on with it.
Okay. All right. Guys, any other questions from anyone else?
No, Daniel's questions covered mine.
Yep.
Okay. All right, great. All right, so no questions, it seems. I haven't graded your exams. I'll have those at some point. And there's no questions about the labs either, right?
Nope.
Not
All right. Okay. All right. So let's get started then. Let me. All right. So let's get started. I'm gonna write my notes here. All right, so Daniel did ask a lot of questions about this lab. So this is a seed lab. Okay, the very basic way that this can be done is with VMs. All right, so the very basic way. Now, I should say you do need 3 VMs for this one. So you will need 3 VMs, okay? So you can work in groups, but obviously every person, every student will need to build this on their physical machine at home, this network of at least 3 VMs, okay? Now, as I said, given that things are different now with social distancing and everything, it occurred to me that it would be possible, if you're at someone's house, say a student is in one house and another student is at another house, that you could implement, you have internet, obviously, and then you have your internal networks. So you could, first of all, I would say do this. But once you've done this example, you could basically take what you've built here and try to implement it, actually in your house, so that you can, establish VMs. You're going to do a lot of routing, and then you can send traffic from your friends, from your house to your friend's house, for instance. But so that's something that we will consider to see how that would work. But for now, we're just going to focus on implementing it on the 3 VMs. Okay, so we're going to focus on implementing it on the 3 VMs. Okay. So what is the basic setup? All right, so let's start with that. Okay, here it is. So the basic setup, the network setup for a VPN, for a VPN, okay, will look like this. So you would have the web, right? And then you would have, for instance, a VPN client. You would have a VPN client. Okay? And then over here you would have, or this is what we're going to have, a VPN server. Okay, so I have a VPN server, but now on the other end of this, so this VPN server is like it has 2 network cards. All right, now obviously our VMs will not have 2 network cards, but instead we're going to achieve that idea via routing. So we'll have to create some routing rules to basically forward packets. So we have to enable on the VM the forwarding option. So this will be connected to another LAN, let's say, and then on this LAN you're going to have another machine. So you're going to have a machine here. Let's call it V, host V. All right, and then this one over here, this VPN client is U. So this is host U, and this is host V. Okay. So we will have to use VMware workstation to do some configuration. So if you remember, you can connect in the editor of VMware. You can set up some like NAT networks, right? So you can set up NAT, bridged, bridge, and host, right? So you can set up these networks. And so we're going to have to play with those to create these connections, okay? So this is going to be a NAT adapter, basically. So NAT network. And then using the host only, we can set up this one, host. So by doing that, we've basically created a VPN, right? So or the environment that we need for a VPN. So let's imagine this is going to be, you know, we're going to have a VPN network that we need to establish. So there's going to be something in all Unix systems have something called the TuneTap interface. It's a virtual interface, and we're going to have to create those interfaces to be able to create the tunnels, right? So to create the tunnels. So what that's going to do is that by doing this, we're going to create a VPN network such as this, right? So that's going to be our VPN network, kind of imaginary, if you will. Between those two machines. So we're going to have to build that as well. And then there's going to be the physical network. So for instance, this would be a 192, let's say 168.60.0, all right, network, and so on. All right, so there's going to be some basically physical networks that we're going to have to establish, and then there's going to be the actual VPN network that we have to establish, okay? But ultimately, once we do our lab, that's going to be the network setup for a VPN. So the lab has, you know, like few problems. The first one is to set up the TuneTap network, and we can test that easily just with like sending one packet across the network. And then after that, we need to build this, right? And with all the routing rules, so we need to add routing rules. Right, and really that's where it comes down to. It comes down to creating these TuneTap interfaces, and also routing rules, right? And basically the configuration that we do in the VMware workstation. So in workstation. Or let's just say on VMware. Okay. All right, so this is the basic scenario. Now at this point, when we build this network, it's a VPN tunnel, but we still will not have done the encryption, okay? Because the encryption is really after you built the VPN and you know that you can send packets through the network, then on the software side, we have to basically add OpenSSL. So we have to add the OpenSSL code and, you know, then encrypt the data, and then we'll be able to send the data across the network. So that's why I would say that a VPN really is made up, you know, and logically speaking, right, a VPN is made up of all the tunnel and routing information, and that would be true if you were doing this on your Cisco ASA as well, right? You have to establish a tunnel, you have to do all the routing that's required. The ASA does that for you basically when you run the wizard, and then after that you have to do the encryption. Once you know that any packet can make it from point A to point B, you know, then after that you can do the encryption as well. Okay? Any questions? All right.
Nope.
Okay, great. So there's no questions. That's and so this is going to be the lab that you have to build. Okay, so that will be the lab that you have to build. Okay. All right. So so today I'm just gonna go over the details of this. I'm gonna go slowly, kind of building up on all the concepts. Keep in mind we will have to write some code. Well, not write some code so much as the code is written for us. We just have to kind of tie it together. All right. So we kind of have to tie it together, and there's gonna be our Unix commands to turn basically some of these devices into routers or routing devices. All right. Okay, the language that we're going to use for the lab is C, all right? You've already looked at C when you did sniffing and spoofing. So sniffing and spoofing. But the code will actually not be as difficult as sniffing and spoofing because we ourselves we ourselves are not breaking up the packets into the individual headers. We don't really have to do that, at least for the tunnel. We can just do it, you know, we can just send the packet as is. So that will make things a lot easier for us. All right, but it'll be C, the C programming language, okay? Now, one scenario that I like to think to kind of motivate why you would want to do this, imagine that you had, you know, VPN obviously protects your information, provides confidentiality, integrity, and all of that. But let's say that you had a home in another area of the world, for instance, and you know you have two homes, right? And so, you know, you want to watch. Maybe the television that you watch, your Netflix or something, is it's locked by geographic location. So whenever you travel, you may not be able to watch all your programs in that other location. So if you had a VPN between these two, you basically connect now both of your homes, and so this router, which is still running on your house, could now be used for your Netflix over here. So whenever you watch your Netflix, you really just go through the VPN, you know, you access it. Maybe, I don't know about the lag. Obviously, there might be some lag there in the quality of the picture, but it's certainly, you know, one application. So VPNs can be very useful for lots of things. Okay. All right. So anyway, so now that we've talked about this, so I should say, so when we were so this is a question Daniel brought up, but I kind of want to address it. So in our school environment, let's say that we had this, right? And if you remember, you guys set up the GUI already. Yes?
Mm-hmm.
You set up the GUI already on the ASA. You would have used the wizard, right? And the wizard basically would have done the same thing. The wizard creates a VPN network, right? So it creates a VPN network. Imagine it's kind of like there, you know, it's like a VPN network. And then it finds, what it needs to do is it needs to have a lot of routing rules. There's a lot of routing now that comes in. Whenever a packet is coming here, it needs to know, oh, this is a VPN packet. I need to forward it to that. When I forward it to that, then, you know, I'm going to forward it back out to the network. Okay? And so that's the idea with what the Cisco does for you, is that it would have done a lot of routing rules, all right, to redirect the packets, because every machine that gets connected to the VPN now gets a VPN, call it a VPN interface. Like if you've done if config or something like that, and so they get VPN interfaces. All right, so our configuration the wizard would have handled all the routing inside the ASA itself, and then it would have handled the crypto as well, right? The crypto. And so that's kind of the same, the same idea, and that's what we're gonna, pretty much pursue in this lab, but just at the software level. So we're actually going to try to see how this is implemented. The other thing is that it relates to a question that Daniel asked about the user account. So the idea is that now that using Active Directory, let's say a domain controller here, Windows Server, whatever the latest version is, you would have two services, something called the Radius server and then Active Directory services. So both of these would have been services that you have to enable on the machine, on this machine, and then when you were doing the GUI configuration, the GUI configuration would have asked you, what is the IP of the Radius server? What is the IP of Active Directory? Okay. So it would have asked all of those questions as you're doing the wizard. And then once that's configured, then basically what happens is when somebody, let's say over here, you have a computer that connects to this switch, the router, firewall. You have a computer, a PC, let's say, that needs to connect to the VPN. Well, this PC should be able to ping all the way to here, right? That's something you tested quite a bit. And then the VPN, the PC needs to have what is called a VPN client software. Client software. It's just usually some program, right? So it would have been a VPN client program that we have installed. In here, you would have used that VPN client to tell it, oh, my VPN server is this one, right? So this was, I don't know, 192 something. Once you use the VPN client, that's, that piece of software, that code basically, this code, needs to connect to the code on the ASA, right? And that code then basically, it has to handle the forwarding of the packets, the routing of the packets, and then once a packet arrives to the right location, it has to handle the crypto. The third thing that it would have handled is the authentication. And the authentication can be handled by Active Directory. So that's just, you have some password over here. And then this password you enter, the device, then the ASA would pass that password to the Radius server, and that's a network authentication. So the Radius server would just check that password, and it would say, oh yeah, I'm the Radius server, and I know that the ASA is authorized to do this. So I'm going to let it access Active Directory services. And then after that, after the authentication of the Radius, then the ASA would authenticate the user and that user's password. Let's call this one token so it's not confusing. So that would have been a token for the Radius server, and then for the user account itself, a username and password, and that would have been what Active Directory would have had. So Active Directory would have been associated with a group, in this case a VPN group, right, that you have to configure, and then also in that group, and also an account. And that account is a member of that VPN group. Okay, so that's one part. Unfortunately, this I don't know how to add into our software lab. So I mean, obviously we could write a lot of code, but to actually make it talk to an Active Directory server, there must be a Microsoft library for that. So I don't really. We might look at another way of doing that, but for now, I don't have a solution for that without our ASA. So, but we can certainly on the software lab do this part, the routing, and take a look at least at the crypto. We don't have to encrypt everything, like absolutely robust. It's more of a, it's a lab, so it's more of we wouldn't have time anyway to do something like that. So anyway, so this is what the ASA lab would have entailed, right? So, VPN client software over here, configure with the wizard the VPN on the ASA, and then have the ASA talk to the domain Windows server. Right? And Windows server then would have two services, Radius, which is sometimes called AAA, for authentication, authorization, and accountability. And then also the Active Directory itself, which handles the groups and the accounts. And then once all of that has been authenticated, then basically this VPN gets the VPN interface, and then now it's basically like they're completely connected. So you can imagine there's like a connection, sort of like that. Obviously, it's through the network, obviously, but you can imagine there's a connection between those two switches or that machine and that switch. And now this machine would have been able to access anything on switch 1. Are there any questions about that, guys?
Mm.
Nope.
Not making sense.
All right. All right. So, all right. So now that I've talked a little bit about this on as it would be on the ASA. Now let's get into the Seed Lab itself. Okay, so let's get into the Seed Lab itself. So this is going to be the Seed VPN. I will post this on the instructions on Blackboard. I think they're already there, but I'll post them. I need to take a look at them. So basically, let's start looking at this. Also, I should say this is if you like reading things. This chapter is chapter 16 of your book. So the Seed Labs book, chapter 16. All right, so let's talk about VPN now from a building this from scratch, right? So that's really the way that we're gonna think of this. Let's say that you decide, you know what, I'm just gonna build this from scratch. Okay, so how does that work? So forget about Cisco or GUIs or anything like that. All you have is a couple of Linux machines and C code. Okay, and so you're going to try to think about how to build something like this. So the scenario is basically that you need some kind of a VPN client, okay, and a VPN server. And usually, you can think of this as just, there's no real difference. Because it's a two-way channel. It's not just a one-way channel like maybe like Telnet or something like that. So imagine it's more like a two-way channel, but you build a VPN client and a VPN server. Okay. Now the encryption here is going to run over something called TLS SSL. So if you remember SSL, secure socket layers, we talked about that in 350. In this course, towards the end of the semester, I will talk about TLS, okay? The TLS aspects of it. All right, so then on the VPN client, you can think of this as some kind of a device. Obviously, you with two network cards, so it's basically a router with routing functions. And then you have two devices, U and V. U and V. All right? So currently, these are going to be in separate networks, right? So this, for instance, could be the 10.0.7.0.24 network, and this would be the 10.0.8.0.24 network. So notice that both of these are kind of mirrored, and they're going to be mirrored throughout the description, just so that it's kind of more consistent, okay? So notice that right now, this is just a VM, VM1, and this is VM2, okay? So we're just building it that way. You could also think, if you're working with your classmates, you could build a VPN of 3 houses. That's what I was getting at, that it'd be nice if, Daniel and Corey and Tink, right? They're in the same group. So each one has in their house one piece of this, right? And so they're going to try to connect the entire network. So each of you would have your own private networks in your house, right? So each one of you would have your own private networks in your house. And so when you do the routing in your house, you have to make it consistent. You are all pretty much making the same rules, but just pertaining to the network that you belong to. So then we would say that 10.0.7.5 is that machine. So that means that this one over here would be 10.0.8.5. Right? So that's that machine. Another thing that's important to think is that in the network, you basically will have like a router, but then everything is the switch here. All right, so this is an important notion. Now, the host, you, is in the switch at the just the same as the VPN service. You see that? So the VPN is in the same switch. It is no different than this one. So they're both pretty much, they could both be, you know, seed VMs or Ubuntu 16.04 VMs. They could definitely be both. But what needs to happen is, usually, you know, we learn in the class, right? You know, we send a packet. If it's in this network, it gets to the machine. If we don't know the network, we send it to our gateway, right? That's, you know, that's kind of what we did. And then when we send it to the gateway, the router either sends it forward to the other side, or if it doesn't know the network, it drops it. Well, the problem is that now we need to tell it to do what? If we want to use VPN, the packet should actually go here, right? It should go here, and then this machine will have some code. Basically, it creates a software application, a program in memory that's associated with a specific port number. Does that make sense, guys? And so if you imagine there's something that receives the VPN on that machine, the tune tap, and that is linked to the code itself. And so the packet needs to, so first of all, imagine there's some routing issues because the packet, as I said, instead of going to the router, if it's in a VPN, if it's going, let's say, to the VPN network 10.08, right? You know that's the VPN that you want to go to. Well, as it turns out, you don't know 10.08 on this network, right? You don't know it there. And so there's got to be a route somewhere, maybe on the router, maybe on the Linux machine that says, hey, I don't know that network, but oh, by the way, you said it's 10.08? Oh, okay, that's a VPN issue. So guess what? I'm going to go ahead and forward the packet that I just received to here, right? And it'll be received by a virtual adapter that we need to create on the VPN machine itself. And that VPN adapter is linked to software. It's linked to code. And from there, the code, imagine, it's going to do all the crypto, if you will, right? If you have the crypto there, so it's like a module, it goes through that crypto and then comes back, the packet comes back, and now again, the service needs to send it out, right? So it's going to send it out back into the network, but this time it has to once again be routed to know, oh, now this is an encrypted VPN packet. Okay, I'm the router. Oh, okay, I know what this is. I'm going to send it out into the network so it goes from, you know, here to there. Does that make sense, guys? Yeah?
Mm-hmm.
No questions? All right, wow. All right, and so once you do that, then on the other end is the same thing, right? Imagine on the other end, the VPN server, you know, comes in, it gets routed. This router needs to know where something is going, right? It sends it to the VPN server, and the VPN server will do the same process, but in reverse, right? So it's going to send it back to the VPN machine, decrypt it and everything, and then finally it'll arrive to the machine that it's looking for. Okay? So as I said, as you can see, this will require us to do some routing rules and also to have some code in the background. So this is, you know, the code will handle the tunnel and the crypto. Okay? So that's the basic idea of what we need to achieve in this lab. Now, in this lab, we're not going to focus so much on the crypto part. You know, we spent 350 covering quite a bit of cryptography, and so we're just going to, mainly for this lab assignment, we're going to focus just on building the tunnel. And then we're going to know in what parts of the code, you know, we would actually, okay, now we need to take the packet and encrypt it. Okay, but you know, it's a quite involved lab, and so that, you know, we first need to worry, is what I'm trying to say. We first need to worry on just making sure that the packets can find their way to their destination. Okay, yeah. So in this case, I should say there, this is the gateway, 10.0.1. All right, so let's move on to the next slide. So now let's take a look at this in a little bit more detail as far as the routing rules. All right, so we're going to do an example now of the routing rules themselves. Okay, so this is still the web. That's the web. Okay, and then we have our routers over here. So imagine, I like to, when I think of this, I like to imagine just, your home and then connecting to your friend's home, right? So basically, it doesn't matter, where they are, but, basically that's the idea. So the router then, is connected to some kind of switch over here. Okay, and this is, once again, the 10.0.7.1 network, and this is the 10.0.8.1. Okay, so as I said, what we're going to focus on here is kind of the routing rules. So here we need to find a way intuitively where we have, again, U, and then over here we have V, right? And this is 10.0.8.5, and then this is, let's say, 10.0.7.5. Again, we're mirroring these. The gateway, we need to define that the gateway for this one is going to be 10.0.7.1. And then here in the service, we have the VPN. We have the VPN client. We have the VPN client. Okay, and this VPN client is 10.0.7.8. So notice this is another IP address there. Our network here is obviously the 10.0.7.024. We can keep it simple. All right, and then on the other end, we'll have the VPN server. And that's going to be 10.0.8.8. All right, so now we have this established. So we have to think about the routing rules. All right, so if, for instance, the router receives a packet with a destination of, so let's say, we need to, in the router here, for instance, this is going to send a packet. It wants to find the network 10.0.8.24. If it wants to find that, right? So this needs to have a routing rule, a routing table, and it should say if 10.0.8.0, right, 24, if this machine U sends a packet to that, then you want to forward that to 10.0.7.8, right? So it'll, it goes to the router and then it needs to come back to the VPN client, because that's the way that you establish the tunnel, which is basically nothing more than encapsulating things. Now, here's the issue though. Now, when that packet, okay, so it gets to the router, right? It gets to 10.0.7.8, and now 10.0.8 needs to have another routing rule. So we need to find a way to give it a routing rule so that the packet, so what's going to happen is the computer is going to receive a packet in its stack, and when it receives a packet in its stack, it's going to try to break it into headers, right? And the moment it starts to break it into headers and it passes it to the kernel, the packet is destroyed. And so, you can't really forward anymore. It's just going up to the different services. So you need to really, in the VPN client's machine, you need to have a routing rule as well. And the routing rule basically says, okay, 10 10.0.75 wants to find 10.0.8 0, something like that, right? So who is that? So router forwards that to VPN client, and then now VPN client also needs to have a routing rule that says if destination let me write it down here. Routing rule that says if destination, or let's just say if 10.0.8.024, right? So if it's looking for that, then where do I forward this? That's the question. Where do you forward that? Because it really needs to go to VPN client, but it needs to go as a whole packet. All right, and that's where that's where TuneTap comes in. Okay, TuneTap is our friend. Okay, so TuneTap is really the mechanism that is going to do all the heavy lifting in our virtual machine. All right, so you will forward this to TuneTap, which is basically a virtual card. Okay, so we will have to set up, bring up TuneTap on the Linux machine. Now that's a default. All Unix machines have a default virtual card, and that's going to be the one. So in a sense, that's why in one of the previous drawings, we had this, right? We had this imaginary interface, the so-called TuneTap. Okay, so we've created new imaginary or virtual cards, and these cards basically they act as an actual network card, but the thing is they are tied not to the network anymore per se, but they're tied directly to programs. So programs within this machine. So imagine you have a program within this machine. That's the C code. Let's imagine you have, that's your code, right? So you have that code in the VPN client. TuneTap will direct that packet into that star, and that's the program itself. And from there, that's the trick, because now you can receive the entire packet, modify it, and then use TuneTap to send it back out. Is that clear, guys? Are there any questions on that one?
Sounds good.
Sounded good. Anyone else? Any questions? You guys still there?
No, I'm still here.
All right, so some of you are still there.
Still here.
All right, yeah, okay, great. So yeah, so well, I mean, you can stop me at any time. As I said, I'm kind of just going over the overview of this, the logic of this, because as I said, you're still setting up a network. It's a network that's kind of imaginary, because you have to use the routing to create the network itself. All right, and so that's the same thing. So just to kind of wrap up this slide, oops. This slide, on this side, you're going to have another routing rule. Routing rule over here. Routing rule, and it's similar. So if, let's say, so on the 10.0.8 network, you want to find the 10.0.7 network, right? Whenever you're talking about VPNs, because remember, that's internal to your network, so you can build it however you want, right? You built these IPs. They're not external IPs, they're internal IPs. So on this routing rule, you can have, if your destination is the 10, should have written here 10.0.8.0. Right? So if your target is this one, 10.0.7, 0.24, then you forward this one, right? Oh, sorry, no, this one, VPN server. So you forward to 10.0.8. 8, 8. That's the routing rule. And then the same logic would apply here then. This needs to have if 10 0 dot 7 dot 024 or then send it to the tune tab, because this machine also has a tune tab. So this machine, so let me draw it, this has a tune tab, right? And then this one also has a tune tab. Okay? And that's basically how that works. These machines are independent, completely independent. They're just in the network. And, yeah. And then it's really routing rules in the router and routing rules in the actual VPN clients to be able to move the packets around. And really, so that very first part of doing this is not so difficult. You'd be surprised that it's not actually that difficult. It starts to get a little bit more difficult once the virtual card sends data in here, because when you send data into that star, remember that that's the C program. And so there we have to get into the C language efficiently so that this is actually somewhat fast, so that you can actually process the packets, etc. Okay? All right, so you can stop me at any time, ask questions. Let me save this just in case I was to lose it. All right, so let's continue. Okay, so now that we've talked about the overall picture of everything, now we can focus a little bit more on this concept of the tune tab. Right. We're going to take a look at that one. Tune tab. So let's provide a formal definition of this. So basically the tune tab is a mechanism in Unix itself, that is used to create a virtual network interface. Okay, so it's used to create a virtual network interface. And so a tune tab, really, the very basic definition of it is that it's an interface, a tune tab interface connects a network computer to a program, Right? So the way that you might imagine it is you have the real computer here, so you have the real physical computer, and usually if it was a router, it would have two network interfaces, right? It would have two network interfaces, two NIC cards, right? And remember, this would have one IP address, and that has an IP address. So this physical machine is connected to the switch, right, and so on. So that's the physical, real computer. And then you have, when you go into the operating system, you create the tune tap, interface. Okay, so you create the tune tap interface, and then that tune tap interface is a virtual interface that allows you to connect to, let's say, that allows you to connect to a program. But a program that is sort of a program pretending to be a computer. So we can say that. So a program pretending to be a computer. And so what that means is that the program is pretending to be a computer, and so it will be able to get a full packet. So, and that is really the trick. That's why we have to do, honestly, that's the reason we have to do all of this, is that to get that full packet so that we can forward the entire packet as it came from, we want to send the entire packet that came out from this network to that network. And so we need to be able to forward it to the tune tap, which is the program pretending to be a computer. Okay, so that's really, in essence, what it is. So actually, if you notice, when I call this the tune tap, right, it's actually two words, right? The tune and the tap. And so it really, it's really the tune tap is actually two interfaces. Okay, so the tune tap is actually two interfaces that serve as these virtual network cards. The tune and the tap. Okay. And so the tune interface is the one that we're going to use, by the way. So this is the one that we're going to use. The tap it's a more advanced concept. We're not really going to need it. We only need the tune part. So the tune interface, basically it works at the IP level. So IP, so that, we're all familiar with that, IP level. And so what it does is the tune will deliver, so tune delivers IP packets to the program. Remember that, the whole purpose of the tune tap is to deliver, packets to the program that we're writing. Remember that this program that we're writing, that's going to be our C programming, or C program. That's the C program that we are writing. Okay. Now, tap interfaces work at the Ethernet level. So they work at the Ethernet level. Okay, so tap interfaces work at the Ethernet level, and basically they are, because of that, they are more powerful, basically, because they are at a lower level, so you can build more things on top of Ethernet. So, they work with Ethernet frames. So in essence, all we kind of need to understand is they act more, let's say, like physical interfaces. Okay, so if you wanted to build, multiple connections, multiple taps, or multiple IP tunnels connected to one Ethernet interface or something like that. But we don't have to worry about this one. Okay, so we will not be, we will only be focusing on the tune itself. Okay, so we've already talked about this. So now let's think a little bit about the steps for a tune interface. All right, so the first thing, imagine we want to bring up we want to bring up so in Unix we can bring up the interface as follows. Okay, so we're going to bring it up as follows. So if you remember, everything in Unix, even interfaces or device, printers, etc., they're all files, right? So they're all associated with the dev folder, right? So in the dev folder, we're going to basically go in there and do this tune interface. So we're going to use, so to do that, we use a function called ioctl, right? So ioctl, okay, so we use that command, and that's a C command. So for instance, you would have a C code, C script, right? C program. And then in there, you're going to use the ioctl command. All right, so this is obviously at this point to create our tune tab, we're getting into the code. Keep in mind what we're going to be doing is we're going to be creating a whole bunch of functions, and then all of these functions we're going to call up from one main program. All right, as we build this. Okay, so the first thing, the ioctl will open. The ioctl will open the dev net tune. Okay, so it'll open this interface or device. It'll open that device, and we'll also register it and register it with the Linux kernel. So it'll register it with the Linux kernel. Okay, so once that's done, once you run the program with that command and that has worked for you, then you can check that the tune tab device is there. So if to show tune tab, the tune tab device, you can try running the command if config -a. All right, I think by default it doesn't show it. You have to add the -a parameter flag, and then it'll show that it's there, but it's not going to be assigned an IP, and it's not going to be assigned anything yet. So then the next step is you have to do that. So I'm going to move on to another slide. So let's just say tune tab steps. All right, and then I think this is the third step. So the third step then is you're going to assign the tune tab an IP and network. Okay, so you're going to assign the tune tab an IP and network. So in this case, it's going to be a Unix command. So it's going to be sudo if config And then the name of the tune tab will be tune 0. So that's one thing that you will see when you run the command if config over here. It'll show tune 0. It's basically like, like whenever you look at IPs, but the numbers will be missing, right? The IP and everything. So once you do that, and the subnet mask, for instance, once you do this command, and you'll do 10.0.8.25, whatever you want to call it, 24, and then like that, right? And that will bring up the interface, and at that point, you have a tune tab. So really, if we go back to that graph, you had the physical machine, and now you have also this virtual interface. And so now that virtual interface can be connected to your C programs, okay, to your C programs that you will be using. Okay. And then finally, once you do this, you can repeat the if config again. And when you run this if config, now you will see the tune 0, but it'll have an IP address. It'll be 10.0.8.25, 255, 0, and so on. All right, it'll show that information. Are there any questions so far, guys?
Nope.
All right. Well,
Sounds good.
all right, great. So it's making sense. That's good. Okay, so these are the steps. As you can see, we're building, basically, we're creating the tune interface there. Okay? Now, all of this, remember, the C code, if you start checking the seed labs, you can probably take a look at all the files already. So those are available. And, as any C program, I should say, it requires some libraries. Right, so the seed VM should have all of those libraries installed already, so that's the good part. So definitely for this lab, you probably want to use seed at least for the VPN servers and clients. Okay, so you're going to go through those. And basically in the code, you're going to define, specific things. Right? So you're going to define the name of the virtual interface, and running with that IOCTL command. I think the script that's provided in the lab actually creates, say it creates the interface, IOCTL. There's some code here, but IOCTL, it does that, and then after that, it'll basically launch. It'll basically launch a shell. So it'll do, if you remember, exec v, and it'll run like bin bash. Okay, so you're going to end up, running this, and it'll open up for you when you run that code. It'll open up like a terminal where that is running. Okay. So what time is it? All right, so we still have some
20
time.
after 7.
Yeah, so we still have some time. So let's go over then. Move on. So let's talk a little bit about routing issues. Okay, so now let's talk a little bit about routing issues. So I kind of gave the big picture of that. And now I'm really just going to go over some of the commands, right? So the idea is kind of take a look at the commands here as well. So, what I'm talking about is before we talked about this, right? So we had like, these routing rules over here, right? And remember, we're implementing all of these routing rules now. They're critical for this to work successfully, okay? And even, for instance, if you built the site-to-site VPN on the physical network, where we had the Cisco ASAs, we would have needed to add some routing rules, just like the one that you added on the ASA, where, you know, if I don't know this network, send it to the gateway. So basically, that's what we're doing. So I kind of want to stress that that's really what we're doing here. Obviously, in the physical network, it was a lot more obvious, right? That we, you know, on the ASA, we put in a routing rule, and that's basically, if you remember, we wanted to get to network, I think, 10.10.10.0, right? But we are sending a packet from the internal network 10.0.1.0. We only know the 192.168.1 network. So we added a route in there to tell the ASA, oh, by the way, when you don't know, 8888 or whatever, just forward it to the router at 192.168.1.1, I think. So that's really what we're doing. It's just a little bit more, the syntax is a little bit different, obviously, because it's Unix, and it might be a little bit more confusing because it's a little bit more virtual. You know, the fact that we have some interfaces that are actually connected to a process as opposed to a physical machine. All right, anyway, so let's talk a little bit about routing. And in particular, let's talk, you know, if you remember, the basic idea is that we're creating an app, right? We're creating a little program that will do the VPN. So it's a, you know, the VPN app, right? And we need to do all the tunneling. And then right? And then to be able to connect to that program, we need to have the tune tap. And then that tune tap is connected to our Linux box. And that Linux box is connected to the network. Okay, so we have, this is the actual interface. Okay, so that's the actual interface, or the NIC card, or, you know, however you want to call it. All right, so now the trick is, this is all happening in a Linux, right? So this is all, you know, all of this is actually the Linux environment. All right, so we want to think then a little bit about how to do a routing table on a Linux OS. Move to a new one, so let's call this Linux OS routing table. OS routing table. So remember the, you know, the basic things, just like we learned that whenever you added ACLs into the firewall, right? So we learned this, that they are sequential. Okay, so routing tables are also sequential. So routing tables are sequential. So what that means, as you know, is that a packet goes and it hits one and there's no match, so it goes to the next one, there's no match, it goes to the next one, until it finds one where there's a match, and then that routing will be executed. Remember that the routing usually means that the source IP and the destination IP are changed. All right, so they're going to be plugged with whatever the new one is. Kind of like spoofing the packet, right? You take the packet and you change. You did that example in Spoofing Lab where you flip the IPs in the code, so you've already looked at that, and that's sort of what's happening there. So to do this in Linux, in Unix, we are going to use the route command, right? So Unix has a command called route, right? And so the goal, so that's the command that we use very simply to create routing rules in the particular machine's routing table. So how do we do that? How do we accomplish that? So I talked about it. If I go back to the slides, we're basically going to address these ones, right? So I don't think, can you guys see my mouse when I move it like this?
Yes.
Okay, great. So basically what we're gonna implement now is these ideas, the routing rules in Unix. right? So how do you do that? So this is what you will actually do in the lab itself. Oops. Okay, so let's go back here. So I'm going to, okay. So there. So that's where we were. So now the goal of this is to basically, as we said, if the destination is 10.0.8.0.24, right? We want to redirect that when, and this is of course when this arrives, we're talking about from the point of view of this, right? So the packet arrives here, right? That's where the packet has arrived. And obviously our goal now is to redirect it to the TuneTap interface, right? So in here, we need to add the routing. Okay, so we need to add the routing rule. And so we're gonna go over here and we want, you know, if this, then forward to tune 0, because that is the name of the interface that we just created, right? So we just created that in the previous step. And so to do that, we're going to enter the routing rule and it's going to be as such. So I'm going to say sudo route add-net 10.0.8.0.24 tune 0, okay? And that's basically it. So that route basically says, okay, if this is the target, forward to that one over there. So as you can see, a lot of this is just adding these. So far, we've done very little coding. It's mainly just adding, you know, some commands on the Unix interface. Then if we want to view it, if we want to go ahead and view it, you can just do route-n, right? And then we'll see that the routing rules have been added into our network environment. Okay. Are there any questions so far?
No.
All right, no questions.
Yeah.
All right, so at this point, I kind of wanna stop here with the lecture. You know, I'll continue, of course, because there's a lot more. So, but this is a good stopping point, I think. On Thursday, the plan is I will go over more of the lab materials. Okay, so I will go over more of the description. You can imagine like the seed lab type of document. Go over that and then maybe have you guys start with the lab. This is not a lab that you can do in one sitting. Okay, so you kind of have to, and you have to really think about it. Okay, so you kind of have to progress through it. There's going to be probably several submissions that we're going to do with this one. So it's not going to be like one single lab because it will take a little bit of time. And so this is probably, I should say, in 454, it's one of the hardest labs after, you know, TCP/IP. What was it? Session hijacking, and then this one, just because this has a lot of virtualization. All right. So yeah. So the plan is I'm gonna stop here with the slides. I will post this video. Hopefully, I'm recording it. I'll post it. I'll post the slides. And then on Thursday, we'll meet again at this exact time, and we'll go over, you know, more details of the lab itself, and then you guys can start working on this. And hope, you know, I've never done this like this, right? So in online, so I'm not entirely sure what questions will be brought up, but hopefully, you know, you're all working. Remember at home, so hopefully everyone has the hardware to have 3 VMs supported. As I said, though, there's the possibility that you could also, if you have a router at home, a physical machine, and a seed VM, it's possible that you could try to connect to your friend's house, right? So if you have access to your home router. So maybe explore that as homework. I know some routers are very restrictive, but other ones, they might actually let you put in some routing rules in there. The way that works is, I'm sure you guys know this, there's like an IP address of the router, like 192.168.1.1 if that's your internal network, and then you can literally open a web application, a web browser, and then get to it. And then there might be a password or something associated with that. As I said, I'm not saying that's required. I don't want you to like ruin your home's internet, but I'm just saying if you're curious about that, you can try that as well. And then otherwise, if you have questions about anything, stay on the on the session, and I just want to answer any questions you may have, or things like that. All right, so stay if you have questions. Otherwise, we're going to stop here for today. I will be posting this video. It takes me about an hour just to get it to create and load. So expect it within an hour or 2 hours. Okay. All right, so that's it. Thank you. I'm going to, at this point, stop the video. Okay, so but I'm going to keep the session open.